Hello everyone, welcome to the solution of LeetCode problem 2962 named count subarray where max element appears at least k times. Here in this problem we are given an integer array and a positive integer k. Now we have to return the number of subarray where the maximum element of the array appears at least k times. Now a subarray is a contiguous sequence of elements within an array. Now here, the array contains 5 elements in the first example, which is 1, 3, 2, 3, 3. The value of k is 2. Now, here the maximum frequency element is 3. So here, the subarray that contains the element 3 at least 2 times are this 1, 3, 2, 3, 1, 3, 2, 3, 3, 3, 2, 3, 3, 2, 3, 3, 2, 3, 3, and 3, 3. So in total, there are 6 subarrays. So we have to return 6. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm, we have taken this example. The array contains 5 elements, which is 1, 3, 2, 3, 3, and the value of k is 2. So here, we have to find at first what is the maximum element in the array. The maximum element in the array is 3. So, what is the maximum elements frequency in this array? The frequency is also 3. That means we can say that the element 3 is the maximum. Now, we have to find the length of the number of subarray presented in the array where the maximum element appears at least k times. That means the appearance, let's say it is APP, which will be greater than or equal to k. Now, let's reverse think the problem. Okay, we can simply conclude this problem that if we subtract the total subarray of this given array and subtract the number of subarray where the maximum element appears less than k times, and if we subtract them, we will find the total number of subarray where the appearance of 3 greater than or equal to k. Suppose, let's understand this problem and algorithm numerically. Suppose in this problem, the total subarray is 20. Let's assume it is 20. And the number of subarray where the frequency of element 3 less than k is 12. So here we can say that if we subtract 12 from 20, we will get 8. That means what this 8 means? This 8 means the number of subarray where the frequency of element 3 is greater than or equal to k. Or you can say that 8 is the number of subarray where the frequency of the maximum element is at least k. And this is how we're going to solve this problem. And for n size of integer length, the total subarray will be n into n plus 1 divided by 2. So now we have to find the number of subarray where the frequency of 3 is less than k. And we have to simply subtract this from the total number of subarray. Now, I hope you understood the reduced problem statement. Now let's see what is the, or how can we find the number of subarray where the frequency is less than 2 for the element 3. We will simply use the sliding window technique. The intuition is very simple. I am explaining it briefly. We are taking a variable size window here. So this is the window, and here the frequency of element 2, the frequency of element 3 is 0. So we can consider it 1 again. Now let's expand the window. Here the frequency of 3 is 1, which is strictly less than k. So we can consider this subarray. And the frequency of, for this subarray, the frequency of 3 will also get 1. But we cannot consider this subarray because the frequency here for the 3 is 2. So we have to shrink the subarray. Again, we cannot consider it because the frequency of 3 is 2. Now we can shrink this subarray here, and the frequency of 3 is 1 here. So we can consider it. And we can expand the subarray here. But in this subarray, the frequency of 3 is 2. So we cannot consider it. Now, for this, we have to shrink it, and the frequency of 3 is 2. So we cannot consider it. Now again, we can consider this subarray. And this is how we're going to solve this problem, or count the number of subarrays where the frequency of the max element 3 is less than k. And we will subtract this value with the total number of subarray, which will be n into n plus 1 by 2. And suppose the number of subarray here is x. So we have to subtract x from n into n plus 1 by 2. And this is how we're going to solve this problem. And overall time complexity of this problem is big O of n because of the sliding window technique. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named count subarray, which has an integer a, an integer k, and a vector a as a parameter. Now, we are taking a map to store the frequency of the maximum element. Now here, we are calculating the maximum element by using the max element function. And here, the pointer I and j is initialized with 0. Total subarray sum less than k initialized with 0, and the total subarray will be n into n plus 1 divided by 2. Now, we are running this loop until j becomes out of bound, and in each iteration, we are increasing the frequency of a of j element to the map. And while the frequency of maximum element in the current window is greater than or equal to k, we have to shift our I pointer to I plus plus, or we can shrink the window and decrease the frequency of a of I from the map. And finally, we have to add the current window size, which is j minus I plus 1, to the total subarray less than k, and increase the j pointer value. Finally, we have to subtract total subarray and total subarray less than k, and their subtraction value will become the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.